So next is the input offset voltage. Yesterday I was discussing about the offsets. So here the diagram indicates what actually is offset means. See in this diagram, the inverting and non-inverting. This is negative terminal of the op-amp. This is the positive terminal of the op-amp. See, both of them are grounded. When both of them are grounded, as you know that we have the formula output is equal to gain into uh, input, difference of the input. So since the both the inputs are zero, so automatically output should be zero. But instead of being it zero, we can see in the we can see in the voltmeter, that is instead of being
Good
the
morning,
needle
sir.
money, so instead of being it zero, the needle is showing some value. The needle has to show zero because both the inputs are grounded. When both the inputs are grounded, automatically the output should be zero, but it is not zero. It is showing some output. There is small amount of output voltage is present here. So how we got this voltage, that is the question now. So how we got this voltage is, see, even though we are making it to ground, that means to make the ground also we'll be using some power supplies, right? Some power supplies we'll be using, and in power supply we'll be having a point where we'll be inserting the wire to make it ground. Okay, so there, because of the malfunctioning of the uh, power supply, where it is giving, even though it is grounded, there might be small amount of voltage which is passing through that particular point in the power supply. Because of that, even though in the display it shows 0 volt, it might be giving some amount of voltage, some zero point 0.5 volt or zero point 0.4 volt. In the display, it might be showing 0 volt only. But while giving out in the wire, there is small amount of current which is passing. Because of that, there is some amount of voltage being given. So because of that extra voltage, which is provided in either of these two terminals, even instead of getting zero at the output, we will be getting some amount of voltage at the output. So this unwanted voltage which is existing across the input terminal, even though both the terminals are made equal or made zero, is known as input offset voltage. The unwanted voltage, see, even when both are made zero, automatically the output should be zero, but it is not zero. It is showing some amount of voltage. The needle is showing some amount of voltage instead of being zero. That means there is some unwanted voltage present at the input side. So that unwanted voltage at the input side, because of which we are getting some output, is known as input offset voltage. So so how to overcome this input offset voltage? So in order to overcome this input offset voltage, what they will do is they're going to the manufacturer itself, himself he will be mentioning. So what is the how we can calibrate it? Calibration means making it to some particular values, making it work to some particular values. To calibrate it, the manufacturer, so I was telling the op-amp example as MIUA 741. So MIUA 741 is one set of a series of op-amp we have. So the manufacturer is going to manufacture this MIUA 741. He is going to prepare a data sheet. In that data sheet, he will be having everything. So till what temperature it can operate, and what is the voltage it can withstand, and what is the maximum input voltage it can withstand, and what is the maximum output voltage it can give, and what is the plus VCC minus V you can give. Like every detail will be present in that particular data sheet. So because he will be doing the analysis of that at different levels, and he'll be making a report on that particular op amp, whatever he has manufactured. From that, in the man, and they'll be mentioning that in the data sheet itself. So this will be having an offset voltage of 0.5. That indicates that there is some difference between the input terminals. Even though they are made equal, there is a difference between the input terminals. So during that time, what we are going to do is we connect some extra battery. See, suppose let us assume this negative terminal is exactly zero, or let us assume that this negative terminal is having some 0.3 volt. extra voltage which is coming, but the positive terminal was 0. But according to the formula, we have the formula as V naught is equal to, we have the formula V naught is equal to what? V naught is equal to V2 minus V1 into gain, right? That gain. So V2 minus V1. Suppose this is, let us assume this is V1 and this is zero point 0.3 and this is 0 volt. So now if I want to make the output as 0, how much I should give here such that my output becomes 0 according to this formula? Say V1 is, according to this formula, V1 is 0.3. So how much my V2, this is V2. So how much my V2 should be, then the output will go to 0?
0.3.
0.3. So what they'll do is they'll adjust 0.3 in this battery and they are going to give 0.3 from this external battery. When they adjust this external 0.3 voltage, then automatically what happens? The entire voltage V2 minus V1 becomes 0 and the output voltmeter will go to 0. So this is how they are going to calibrate it while using. So they'll come to know that, oh, there is some difference between these two. Even though while keeping voltage, suppose let us assume instead of making it ground, they'll be keeping 5 volt here, and they want to show that output is 0. So during that time, can you tell me how much they had to keep? From the power supply, they'll be keeping 5. But actually, how much the power supply will be giving? 5.3. In the display, it will be showing 5, but actually it will be giving 5.3. So now what I should do at the other terminal, instead of giving 5 volt, I should give 5.3 volt, because I already know that there is a mismatch between these two terminals. So what is that mismatch we are having between these two terminals? Zero point 0.3 is the mismatch we are having between these two terminals. Even though these two terminals are, this is the terminal of one transistor, this is the base terminal of the other transistor, and we are assuming that they are identical transistor. Even though they are identical transistor, because of any other reasons, the terminals will be having different voltage uh, levels, or input will be having some differences. So even though they are made up of identical transistor, but still because of the problem of power supply or because of any problem of the base, so it will, instead of taking 0, it will be showing some voltage. It might happen either in minus or plus. It might happen in negative terminal or it might happen in positive terminal. So the overall, the unwanted voltage that exists across the input, because of which there is some output voltage, is known as input offset voltage. So in order to nullify this input offset voltage, what we do is we add an additional battery to one of the terminals and we are going to make it 0. This is what we are going to take the precautionary measures. So they will ask you, explain input offset voltage, 4 marks, and how you are going to nullify the effect. So input offset voltage is unwanted voltage which exists across the input terminals, because of which there exists some amount of voltage even though both the input terminals are equal or both the input terminals are grounded. This is input offset voltage explanation. How you are going to nullify it? We are going to nullify it by adding some extra DC voltage across any one of the terminal op amp, and by adjusting that battery or adjusting that extra voltage such that my output voltage becomes 0. This is how we are going to nullify the extra voltage which comes at the output side. Okay. Next is output offset voltage. The presence of small amount of voltage when V1 and V2 are equal or 0 due to the input offset voltage and bias current is known as output offset voltage. So I was telling there is some presence of input because of which we get some output. Same definition. Presence of output voltage because of some unwanted voltage at the input, even though V1 and V2 are made equal, or even though V1 and V2 are made same, is known as output offset voltage. Okay. So it is just like you can the definition is just like converse. So when they ask you output offset voltage, you should tell the presence of output voltage because of input offset voltage. If they ask you what is input offset voltage, the presence of the unwanted voltage at the input terminals because of which we get some unwanted output voltage is known as input offset voltage. Just the converse will be writing. Next is power supply rejection ratio, PSRR. So power supply rejection ratio, the definition is very simple. What you have to write is change in input offset voltage with respect to change in one of the power supplies. See, for the op-amp, we are giving, this is input terminals, whatever we'll be giving, this is separate. This is the input signal which we want to amplify. But this plus VCC and minus VE is what? It is plus VCC and minus VE is are the terminals which we will be giving, the power supply which we will be giving to the transistors which are present inside the op-amp. Say this plus VCC and minus VE in other way, we can tell this plus VCC and minus VE are the voltages which we require to switch on. Just to switch on, this is the voltage. This, what is this input voltages? This is the voltage what we want to amplify or on what we want to work on. Okay, this is mandatory voltage. Plus VCC and minus VE is mandatory voltage. It is just to switch on. To switch on, that is a mandatory voltage. But what is this? This is the voltage what we want to amplify. Right? So it is just like you have an amplifier and you want to amplify. Just an example of music system. You have an amplifier. So where you'll be using a mic, and from the mic you'll be giving the signal, and the amplifier is going to amplify it, and in the speakers you are going to get a output. Okay. Now the signal what I am giving, whatever we are giving, which needs to be amplified, is this signal. This is a signal which we want to amplify. Then what is this plus VCC and minus VE? That is the voltage which is required to switch on my amplifier. See, we have to first plug in the amplifier to 230 volt supply, right? Then only it can work. So the voltage which is required for the amplifier to work is plus VCC and minus VE. Then what is this input voltage? This is the voltage which we want to amplify. That is the difference you should understand. Okay, this is to switch on. This is which we want to work on. Switch on, this is what we want to work on. This can be 0. So based on that, correspondingly it will give output as 0. But in order to give output as 0, this should be on always. Plus VCC and minus VE. Then only the op-amp will be working. Okay, so that's about. So power supply rejection ratio. See what happens is sometimes even because of this variation, I told you this plus VCC and minus VE are acting like uh, the switching on supplies or switch on supplies. That means because of which this op-amp will be switched on. So even there is some variation in this plus VCC or minus VE also, there will be some effect over the input terminal. Because of this variation also, there exists some input offset voltage. As I told, input offset voltage is the unwanted voltage which is present at the input, because of which we will be getting some unwanted output voltage. So this unwanted input voltage even exists because of some fluctuation in plus VCC and minus VE. The same definition we are going to explain here. So power supply rejection ratio is, it's the rate of or a change, a ratio of change in input offset voltage. Input of VIOS means input offset voltage to change in one of the power supplies. See, we have two power supplies, right? Plus VCC and minus VE. Change in one of the power supply, keeping other power supply constant. Or we can explain. So VIOS, it is the change in input offset voltage, ratio of change in input offset voltage to change in one of the power supply, keeping the other power supply constant. That means that fluctuation might occur at plus VCC, or this plus VCC might be constant and the fluctuation might occur at minus VE. So either of them can fluctuate. So because of that fluctuation of plus VCC or minus VE, we'll have some extra voltage which is coming at the input. So that is known as power supply rejection ratio. Next is input bias current. So input bias current means, see here, uh, we know that the negative inverting and non-inverting terminals, whatever we are giving, actually these are what? These are the terminals, and in the last class we have discussed about the ideal op-amp. From the ideal op-amp we came to know that inside this op-amp, what it contains, a basic op-amp contains two transistors in it, and the input to the op-amp is the input to the transistor, input to the transistor. So which terminal of the transistor will be getting this input? May I know? Which terminal of the transistor will be getting, or can I know that which terminal this is? Which terminal of the transistor is this terminals? Anyone? Hmm?
P,
Yes, yes, tell me. Which terminal of transistor these two terminals belong to?
N terminal.
Huh? See, transistor has three terminals, right? Emitter, base, collector.
Yes.
Base, right? Because this is input will be going to what? Base. In the last class we have discussed, no? The ideal op amp. V1 goes to what? Base of this transistor. V2 goes to base of the transistor. And we take the output across the collector that comes across output side. This V1 and V2, they exist across the one side, and this one comes at this side. This is plus minus VE, this is plus VCC. Internally, this is what the circuit it is having. Externally, we show it as a symbol of a like a triangle. Okay. If you have any doubt, you can ask at any point of time. So now here, suppose in this case, there is some both the input terminals are grounded. Both the input terminals are grounded. When both the input terminals are grounded, so during that time, my input current should be zero. My input current should be zero because I have grounded them. Okay. So during that time, both the transistors, whatever I'm using, both the transistor should be, since they're identical, both should show zero base current. Okay. So, but what actually happens is, ideally no current flows through the op amp, but practically op amp has some input current which is very small. Most of the op amp use differential amplifier at the input stage. Two different stage of differential amplifier should be biased properly, but practically it is not possible to get exact matching of transistor. See, we tell both there are two transistors used inside this op amp. They are identical, but practically matching them exactly is very difficult because they are made up of semiconductor material. So, because of small difference in doping, that might uh, create some variations, or the identicality between the two transistor might differ because of that small amount of doping. So it is not so easy to match both the transistor. The input terminals conduct small DC current. This base current of two transistor are nothing but bias current denoted by IB1 and IB2. So the input terminals, whatever we are having, and we know that the input terminals of the transistor is base. Since base is having maximum resistance, and also we tell that the input impedance of an op amp is very high. When the input impedance of op amp is very high, obviously the current through the base very less. But still, obviously there will be very less. At the same time, both of them should be having same amount of current. This IB1 and IB2, if both are given with 5 volt, so then IB1 and IB2 should be same, but they'll be not same, they'll be different. So in order to find the bias current, input bias current, what they'll do is they'll take the average of these two, IB1 plus IB2 by 2. So by taking the average of these two, they'll find out what is the input bias current of an op amp. So input bias current of an op amp is the average of the two input signal. Input bias current is the average of the two input signal. Next is input offset current. See, just there is different input offset current, input offset voltage. Voltage means it is the unwanted voltage which exists across the input. This is unwanted current which exists across the input. So how does this input offset current exist? This input offset current exists because of the difference between these two input current. The difference in magnitude of IB1 and IB2 is called input offset current, IIOS, where IB1 and IB2 are bias currents of the input terminals of the op amp. So here, even though we tell both of them are ideal transistors, and automatically both the terminals should have same current or anything, but still what happens is both of them will be having different input current because both of them might offer different resistances. So when they offer different resistance, automatically they will be having different currents. IB1 and IB2 will be different, and because of the difference in these two input currents, we will be having some current, even though they are made zero, or even though they are made equal, but they will be not same, because if they are same, then IB1 minus IB2 should be equal to 0, but it will not be the same, it will be different. Okay, so they'll be not same. IB1 and IB2 will not be same, they'll be different. So when they are different, automatically instead of being it 0, when I subtract each other, I should get 0 because they are same, but they will be having some difference among them. Even though the input given to them is same, the current IB1 and IB2 should be same, but it will not be same, it will be having some difference among them. So because of that difference, there exists some amount of current. That current is known as input offset current. So difference in magnitude of IB1 and IB2 is called input offset current, where IB1 and IB2 are the bias currents of the input terminals of the op amp. So this is about the characteristics. Till here, you need to understand and explain the characteristics. They usually give the question like this: explain the or define the following, and they'll give A, B, C, D: input offset current, input offset voltage, um, skew rate, all like that. They'll be asking. So what is PSSR, PSRR, CMRR? So they'll give A, B, C, D, like that. So you have to explain. Two marks will be given to each of them. Then you have to explain it in detail. So wherever figures are there, use the figures and draw them and explain. Wherever you don't have figure, just write the formula and explain or define them. So that is about the characteristics. After characteristics, there are small the problems we are having. So here, if base current for the transistor is differential amplifier 8 micro and 12 micro, that means IB1 and IB2 is given. Determine input bias current. See, input bias current means average of the two signals. Input offset current means difference of the two input signals. Here we just take the magnitude. So when I take the magnitude, so during that time, even though they give, just for the confusion, minus 8 microampere, but still here you should take it as 8 microampere because we just take the magnitude. So this is the input offset current formula, just substitute, you'll get. And for this, in this, they're asking calculate the value of the two input bias current. Here, what they have done is they are giving you the final input base current and input offset current values. So they're telling this is the IB value and this is uh, IIOS value. This is IIOS value. So IB value and IIOS value they are giving. So now what you have to do is you have to take out the formula. IB is equal to IB1 plus IB2 by 2. And as you know, IB is equal to what? 60. 60 nanoamperes. Just cross multiply 2 into the 60. You'll get 120. So you'll get one equation as IB1 plus IB2 is equal to 120 nanoampere. And other one, you know that it is the difference. Input offset current means it is the difference between the two currents. IB1 minus IB2 is equal to 20 nanoamperes. So you'll get two equations. Solve them. You'll get IB1 and IB2. And this is the parameter value. This is very important. This table is very, very important. So you should know what is the symbol, what is the ideal value, practical value. So sometimes they can ask you even directly this one also list the